Okay, let's get back to the situation. So we've just discovered that the rest frame is T0, and that's 2L on C. Okay, so now let's have a look at the moving frame of reference. With this, you'll need to exercise a little bit of your mind's eye and determine what's happening with a little bit of visualization, and then we'll break it down into its most simple pieces. Okay, so let's have a look now. You'll notice in this situation, what I've actually got here is I've got a outside observer, okay, as well as the person inside the frame. So this person here is in the rest frame, and because this person out here can actually tell that the train's moving across, well then he's actually got an external point so he can tell that the train's moving. So because this person can actually tell that the train's moving, we say he's in the moving frame of reference. Now, the way I've notated this here is to say that the moving frame, we're going to notate that as with a little subscript V. Okay, so if we think about our light clock now, instead of our light clock moving straight down, or our light ray moving straight down, back up, go and click, what we actually find is because the train is making its way across, as the light comes down to the mirror, it will actually make its way down, hit the mirror, and because the train's still continuing to move across, it will make its way back up, then hit the detector and go click. So what you'll notice is the person outside the train doesn't see the light just go straight down and back up like the person inside the train. The person outside the train actually sees the light follow this path. Okay? And we'll remember that the speed of light is constant from all frames of reference. So the speed of this light here is still c, okay? But we can analyze this diagram and analyze this situation and determine a few things. So we're going to use speed equals distance over time again, and we're going to analyze what's happening here. So remember, the train's moving with some velocity v to the right, okay? So let's have a look. So if we've got speed equals distance over time, the first thing we can determine is the distance that the train carriage has actually moved. So to determine this, okay, we know that the velocity of the train is v. Okay, so here we go. V is the velocity of the train. The distance, well, that's what we're going to try and find. We're going to try and find this distance here. Okay, how far across the train carriage has gone in the time it's taken for the light to go back down and back up again. Okay, so we simply rearrange for D. Okay, and we know that the time taken here, because we're observing from the moving frame, instead of calling that TO, we're going to call that TV. Okay, so you can see here the substitution. Let's have a look. The velocity of the train is V. Okay, the distance is D, and this time taken for this light clock is going to be TV. Okay, so if we rearrange this equation now, we get D equals V TV. Okay, so I've simplified this diagram a little bit more just here. Okay, so if you have a look, I've pulled the triangle out, if you like, all the congruent triangles, and I've got this distance across here is VTV. So this distance here, which I've marked out in yellow, is just VTV on 2. Okay, so you might stop for a moment here. Notice that the length L of the train carriage, L, is still L. Okay, so you might stop for a moment now and just stop the video, and you might actually determine this hypotenuse using Pythagoras' theorem. Okay, so apply c squared equals a squared plus b squared and get an expression for c here. Okay, so pause the video, do that, then come back. Okay, so you've derived an equation for c. Okay, I'm pretty sure that what you'll get is this equation over here. You'll get c equals the square root of l squared plus vtv on 2 all squared. Okay, now because we're determining the distance that the light has travelled, okay, the light, what we've determined in our expression is just one leg of the journey. Okay, so we need to times that by 2, okay, to get the total journey. Okay, so we know that the distance is just the speed of light by the time, just using the same equation, and we know that that's equal to 2 lots of our expression for c, which we found here.